Hi students, today is 14th of April 2020 and we are going to continue our learning on orifice meter. So in the previous video we have seen the derivation of orifice meter. We have seen how the orifice meter works, where it is installed, what is the purpose of it. Okay, small recap. Orifice meter is a type of a fluid flow measurement device which is used to measure the rate of flow of a fluid in a pipe, and the discharge Q value is obtained by the Bernoulli's equation, and using the Bernoulli's principle and the differential head, we are going to get the value of Q will be equal to CD into A0 into A1 root of 2GH divided by root of A1 square minus A0 square, where CD is the coefficient of discharge of an orifice meter or for orifice meter. A0 is the area, cross-sectional area of the orifice, or A1 is the cross-sectional area of the inlet or the section 1. H is the differential pressure head, okay, and A1 square and A0 square remain the same. So this particular formula is very similar to the Q formula that we had derived in venturimeter. Now we will solve one or two numerical problems on orifice meter. So the first problem, 6.22, an orifice meter with orifice diameter of 10 cm is inserted in a pipe of 20 cm diameter. The pressure gauges fitted in the upstream or the downstream of the orifice meter gives the reading of 19.62 Newton per centimeter square and 9.81 Newton per centimeter square respectively. Coefficient of discharge for the orifice meter is given as 0.6. Find the discharge of water through the pipe. See, if I want to find out the Q value, the Q will be given by CD value. I should know CD. So CD is given to you. Okay, you have coefficient of discharge over here, that is 0.6 given to you in the problem. I should know A0 and A1. A0 is the orifice of A0 can be found with the help of orifice diameter, which is over here. I can also find the A1 inserted of the initial pipe diameter as 20 cm given to you, so I can find A1 value. H can be found, right? P1 minus P2 divided by rho g. I know P1 and I know P2, so I can find the difference of it and I can do that. So H can be also found. So I can directly find the Q value, right? See, don't get confused with the upstream and downstream, okay? This is your upstream, section 1 will be your upstream, section 2 will be your downstream. The flow is from left towards right. So something before the orifice meter is the upstream, and the section which is after the orifice meter is the downstream. There is nothing challenging to understand the upstream and downstream, I think so. So to find the Q value, now we will see the solution. D0, the orifice diameter is given to you. Okay, find the area, pi by 4, 10 square. D1, the pipe diameter, section 1 diameter is given to you, 20 centimeter. Find the area, pi by 4, 20 square. Keep it in meter square, that is much better. He has worked for centimeters, okay? Because see, the pressure he next converts into Newton per meter square. Now you will get confused with these units and you will make mess of it. So please convert this into meters, okay? So pressure 1 is given Newton per centimeter square. He is converting it into Newton per meter square. He is finding P1 by rho g. Similarly, he is finding P2 divided by rho g. The liquid which is flowing through the pipe is water, so rho is 1000, so you can find it out. So H value will be P1 minus P2 divided by rho g. I can take rho g common out here and I can find it out. So it is 20 minus 10, so 10 meters of water. See, after finding meters of water, he is again converting into centimeters. If you want to convert it, why? Because he has kept the area in centimeters. The better is you convert area into meters and then work out. That will be much better. So no need to convert these meters of water into again centimeters. CD value is given to you. Now it is mere substitution. Go to your Q equation, CD A0 A1 divided by root of A1 square minus A0 square into root of 2GH. All the substitution, just substitute the values of all the, what you can say, variables in a proper unit, proper single unit. Either everything should be in SI or it should be in CGS system. So convert everything in a single unit and you substitute out here. You will get the final Q value in terms of liter as 68.21 liters per second. So this is the rate of flow or the discharge. Let us go to the next problem, 6.23. An orifice meter with orifice diameter 15 centimeter is inserted in a pipe of 30 centimeter diameter. See, I know D naught, 15 centimeter, so I can find A naught. One is done. The next thing, I know D1 pipe diameter, so I can find A1. So two things are over here. The pressure difference measured by the mercury oil differential manometer on the two sides of the orifice meter gives the reading 50 centimeter of mercury. So he has given you the reading of the differential manometer which is fixed. Now this particular concept is very similar to your venturi meter. You have case 1 and case 2, and if it is an inclined venturi meter, then you had a case 3 and case 4. The same H value, the same cases can be applied to the orifice meter also. Okay, case 3 and case 4 is not generally generally what you can say applicable for orifice meters. Case 1 and case 2 can be done. That is, the case 1 is a case where the manometer liquid is heavier than the liquid which is flowing through the pipe, and case 2 is the vice versa, where the heavier liquid is flowing through the pipe and the manometer liquid is lighter comparatively. So here it is a mercury, and the oil which is flowing in the pipe, it has a specific gravity of 0.9. So definitely it is case 1. So H value you can directly find from the first case equation, where H is equal to X into specific gravity ratios minus 1. See, always the specific gravity of the manometer liquid will be at the numerator part, and the flowing liquid in the pipe will be at the denominator. So that is the specific gravity ratio. Okay, so X into specific gravity ratios minus 1. So X is 50 over here. Please convert it into meters. That is much better. So substitute, you will get so much meters of oil or so much centimeters of oil. Fine. So after you find, okay, you know D naught, you are finding A naught, you know D1, you are finding A1, you are finding H value also from the manometer reading. Okay, if the manometer is used, then only this H equation, H is equal to X into specific gravity ratio minus 1, or H is equal to X into 1 minus specific gravity ratios. That is going to come. Okay, if they are fixing a direct pressure gauges and telling you the pressure value, then you need to find P1 minus P2 divided by rho g. Okay, so this H value is also equal to P1 minus P2 divided by rho g, which is irrelevant in this particular problem because X value is given to you. They are using manometer. Now you need to find the rate of flow given that CD value is 0.64. So coefficient of discharge is given to you as 0.64. So use this data, go to your Q equation, CD into A0 into A1 into root of 2GH divided by root of A1 square minus A0 square. I know all the values over here. Everything is known to me. So I can directly use it and find out the value, right? So you are getting the, what you can say, H value as 705.5 centimeter of oil. Okay, see, this should be, this H value should be with respect to the liquid which is flowing through the pipe. Very important it is. You are going to get it like that only. Don't worry about that. So convert it into meters. Okay, everything let it be in SI unit. Okay, so CD, substitute A0, all the A1 value, root of 2GH, H value substitute, root of A1 square minus A2 square, do the substitution, do the simple mathematical calculation, convert everything in liters per second. So you will get it around 137.414 liters per second. So these are the two problems. Okay, very simple problems that you can actually solve on orifice meter. So with this, I'm going to end the video today. I'm requesting all students to listen to the short videos which I'm doing every day and I'm sharing with you. Thank you. We will meet with the next video tomorrow on Peter TV. Thank you very much. Bye.